So the biggest scope that a program has is a namespace. And a namespace is a virtual folder which holds your classes. A namespace can have a nested namespace within it, so you could say that the namespace can hold either a class or another namespace. So anything that is outside this namespace does not exist unless it doesn't exist inside this namespace. It doesn't know about other things unless you use a using keyword. And what the using keyword does is it lets us use a different namespace. So based on that, we can do a conclusion that system is a namespace. So we're using a system namespace. Now, a smaller namespace is a class. Everything inside a class belongs to that class, and everything in another class, and one class, the other class, doesn't see things from the first class. So I have two classes, birthday and baby. So birthday doesn't know what baby has unless I use it. So baby uses birthday, and that's why baby can have stuff that birthday has. This is a bit wrong. No, it's not. Never mind. Okay, so that's how scopes work. A smaller scope would be a method. You have this method, baby, which is a constructor. About that a bit later. So everything that is inside the scope does not exist in this scope. So you have this small scope of a baby constructor, and everything outside of it doesn't know about the inside of this scope. But this scope knows everything about the outside, about the inside of the baby. So that's it for about scopes. Now more about classes. What is a class? A class is basically a blueprint for building objects. Instances of classes are objects. And that's the base of object-oriented programming. We have a class baby here, and what that means that a baby is defined with some properties, and those properties are unique for each baby. It doesn't have to be unique, but each instance of a baby can have its own values of, in our case, name, months old, and birthday date. So that's our baby. Classes are usually entities of our business, are representations of real life things. So a car, a house, a window, sky, earth, planet. Earth is not a good example, but planet. Earth would be an instance of a planet. Universe, and so on and so forth are examples of what a class can be. So we have our baby class, and that means we can create babies from a baby class. Now let's see, what does a baby have? A class has, just like a function, variables. But variables in class are called differently. A class can have properties and fields. Fields are private variables of a class. So in our case, we have private string name. This is a field because it's a private variable of this class. Now we have name, And name is a property. A property is something that defines how we set and get a field. So a property is something that wraps a field. So we have our name, which is capital N, aim, and we have underscore name. So capital name is a property and underscore name is a field. So capital name is a property of underscore name. So it defines how we set and get name in this case. Why do we need properties? Properties are usually used just because we think about the future. Since property is usually used when a field is public or protected, when a variable is public or protected, it means we expose our class to the public. And since it means that we expose our class to the public, that means that if we want to make a change to it, it will have to be changed in many places, potentially more than a few. And that means that every single place will have to have a code change if you want to keep consistent. For example, we set our name. Let's say we want to log the fact that we set our name every time we do it, or we want to set the name in the database as soon as we set the name, as soon as we set the underscore name value. So in that case, we would need to add some database layer or logging layer to the setting process. And if we didn't use a property, we would have to do it in every single place where we used our name, underscore name. Or we would have to write a special method for it. But why do we need to write a special method for it when we have a property? So that's the use of our properties. Also, another point why we use properties is encapsulation. Encapsulation is one of the principles of object-oriented programming. Encapsulation means that we don't access our variables directly. We encapsulate them in a method in one way or another. So property is the right way of encapsulating our private function class variables. So why do we use classes in general? Like I said, classes are a representation of real-life objects. Anything can be an object. So when we know what properties, what things define our objects, we can make abstractions of them, manuscripts for them, and call them classes. And those classes wrap things we can do with those objects, and properties we define them, with which we define them. So in our case, we have a baby class, and a baby has a name, months, which says how many months the baby is old, birthday, which says when the baby was born, and a constructor in which you pass a name and date time, birth date. So in order to create an object, we need to define its constructor. Let's say in our case we don't have any constructor. That will mean that the baby will be, so that will mean that there is a default constructor for this class, and every class has one. Every class has a default constructor which has no parameters. So public baby, that's what every class has by default. But if you use this constructor, which is with parameters, then this default constructor disappears unless you specifically define it. So if I define this constructor and this constructor, that means I can create a baby either by passing no parameters or by passing 2 parameters. And both ways are valid. Usually, default constructors are used for setting default values for our class objects. So in our case, we can say that default baby is John, and it starts with 0 months, and its birthday is at now. I mean, we create a birthday. So new birthday, which is date time now. So a baby without parameter will be born now. It will be 0 months old, and its name will be John. Another constructor could mean that a new baby which is born will be having a name that we set, and it will also be 0 months old, and its birthday will be not now, but this one that we passed in a constructor. And it makes sense to write one more. So last baby will be who is also born now, except that it will have a custom name. So we have 3 constructors, each defining how we build our baby object. And each of them is quite useful because it shows us 3 different ways of how it's being built. Let's use our baby object. Let's try to create it. So let's go to the program class and try to do some experiments. Now, let's go back quickly to the baby class and note that baby namespace is called lesson 1, OP lesson series, lesson 1, classes and scope. And if we go back to our program, we need to reference somehow to the baby class because, like I said, it's outside the scope of our class, of our program class. Our program class is in OP lesson series, but our baby class is in OP lesson series lesson 1, classes and scope. Note that just because our folder seems to be in higher level, which is OP lesson series, that doesn't mean that we by default include the inner folders, which is lesson 1, classes and scope. So we still have to include it. The name of a scope means a path, but it doesn't mean that everything inside the higher path gets included. So this full thing is needed for us to include a namespace that we want to use, and we include our namespace by the using keyword. So we have our starting point, which is a program class, and main method is the function which gets called when we run our program. So if we go and try to play with our baby, we need to create it. So we say that baby, since we included our namespace, we can use the baby. So we have a baby, and we can create a baby. Different kinds of ways of creating one. So first, baby without parameters. Then the second baby with one parameter, which is a name, Michael. And then last baby with a date time. So Ronnie and date time now. Though it doesn't make sense to say date time now because that's by default. So let's just create a new date and put in 2018. Month is May, and day is 4. So we have our babies. Now that we have our babies, we can do something with them. So let's put all babies into the array of babies. We can do it by opening those brackets and feeding every baby in. And we can do a for each. So for each baby and babies, we print them. So we print information about each baby. So baby is with this name, but I'll use string interpolation, which is $. So we can do something like name is this. Then we can do something like age is baby months, and lastly, that's enough about baby. So we do a for each and we print information about our baby. If we hit run, Ctrl F5, it compiles our program and it says name, John, age 0 months, name, Michael, age 0 months, name, Ronnie, age 0 months. Let's make a small change in the baby class because I think it doesn't really make sense to call a baby with to create a baby with a custom date but still at the same time keep it 0 months old. So we can do a few things now. We can calculate the months, how many months is the baby old. So it's date time now minus birth date, birth date, months, month, and at the same time we add one to it. I think doesn't make sense. So based on this, the month will be if it's the same month, it will be good, I think. but we don't want to keep this minus, so we can do something like if birth date is more than a birth date dot birth date is more than date time now, we can throw an exception. No future babies allowed. And we need to say a new exception. Just like a class and an object, exception is just another class and an object. So just like baby was a class and new baby was an object of a class, so is an exception is a class, a new exception is an object of an exception class. So if birth date is more than our date that we are at the moment, then that baby is not allowed. We don't allow future babies. And at the same time, if birth date, also when you throw an exception, it immediately stops execution of your program. It breaks it. So throw an exception, throw. So also if birth date oh right, I think I know how to make this a bit better. So if birth date difference var birth date difference. So now birth date difference, we use var keyword. Var keyword means that we guess what type it is. Compiler guesses it, not compiler but interpreter guesses it. So sometimes when you don't care about the type, you can just do that. So datetime now minus birth date. Alright, so it's a difference between dates. So it's another datetime object. Sorry, it's time span. In this case, since I guessed the type of an object wrong, it makes sense to keep it specifically like this. So its months old is total days divided by 30. It's double. And we round it up. That's good. That's really good. So we do math dot round. We round it up. Oops. Round it up. By 0. Why can't I divide it? Double. Why can't I divide it? Oh, okay, it's still double. That's good. Mm, that's a bad thing that we both did. It's floor, actually. Floor. No, don't do it. That's bad. Floor is good. Returns the largest integer less or equal than the specified. Yeah, that's what I want. Floor. And now you can convert it to int safely. Okay. So we took the months, the days, we divide by 30, and we get how many months was the baby has the baby had, and we set that as the months. So if this months var months difference is if it's longer than uh, 20, let's say, we can throw an exception saying a baby no longer. Let's make it more expressive. This baby is too old. Too old. And the exception will have birth date, months difference is more, old, months old is more than 20 months. 20 months limit for a baby. I'll split it into lines. Yeah, all good. And now that we have this, we can split it in a method which says private date int count baby months, and we put in date time, date birth date, and we can pass the months in here. So in the end, we return months difference if it passed our exception check. And that looks pretty nice. So we count baby months. All good. So that's our baby. Let's go back to program class. And let's try to create an invalid baby. So baby 4. Okay, thanks. Let's include it into the array, baby 4. And if we hit Ctrl F5 and run, we see unhandled exception, no future babies allowed. That's good. A solution would be to try and try creating babies. Actually, try doing everything. I'm too lazy to put it outside the scope. So the thing about this, you have main scope and try scope. So if we wanted to split this outside, we would need to put the babies outside as well. Let's do it. Baby, 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 baby. I'll copy paste. So we have our babies. We don't need to redefine their types anymore. And we have our babies, and we can say that we know what the exception will be, so we can go ahead and say wrong baby, more like invalid baby. And print the message, e.message. So we don't want to rethrow it, we just want to print info about it. And so if baby so it prints invalid baby, So if baby, so we will change a bit that when we print a baby, if baby isn't null, we print information about it. Sadly, we cannot do it. So if we catch our exception and if one of the babies was okay, we call each baby null. That is the solution. Okay. Because otherwise we cannot put them into array. So an uninstantiated object is null. This baby 1 and baby 2 have the same value now. They're both uninstantiated, and thus they're both null. So if I write this, it's still the same, and my line 39 said that I cannot use babies that might be uninstantiated. But it was more of like a very, very severe warning, and that's why it didn't let me use it. Now, when I wrote it like this, I explicitly specified that I understand that baby 1 is null, and that it might stay null after the try block. So now, since the interpreter knows that I did that, it no longer gives me an error. And I also check that if baby is not null, I print its information. So let's try and run it. So if I hit Ctrl F5, now I have the printed information about babies along with an error message that says no future babies allowed. Let's try one more thing. Baby 5 to test our last thing. So baby 5 was born 2016 might be not good enough. 2006, yeah. So there's a one flaw with our program. Actually, many flaws, but the main flaw right now is that we try to create babies, and as soon as a baby fails, it throws us an error message. For this reason, we need to split to try catch each baby if we want to print every message for the baby, for the invalid baby. We know that those two are always correct, so we can move them outside the try. This one is also correct, so let's move it outside too. In this case, you shouldn't be moving this outside, but since it's hard-coded, it's okay-ish. And let's copy-paste our try-catch and put this one in here. Let's do some refactoring, some small refactoring, but before that, let's run our program. And now you can see invalid baby, no future babies allowed. Invalid baby, this baby is too old. 144 months is older than 20 months limit for a baby, which is both true, and we just made a small validation with immediate error on return on invalid parameters that we passed the baby. We shouldn't be adding try-catch for a baby, so let's for printing invalid parameters about baby, so let's just make a private static method for the program class. We sadly cannot do it as well. Actually, we can. Okay. Private private, come on, I'm creating this in the wrong place, so it was giving me wrong autocomplete. Private static try create baby. We take this and we say string name, date time, date, and we try to create a baby. Baby we pass in name, we pass in date, right? And all good, and we return a baby. Now, yeah, sure, let's give a default value of null, even though it's null by default, but we have to specify it's not quite safe. And now we can change it a bit by writing try create baby Ronnie. Try create baby questionable. So let's move it there. 4 and 5. The parameters are absolutely the same. The parameters are absolutely the same, except date is the future. Now we don't need to do redundant stuff, and now we don't need to redundantly try and catch, so it's handled for us. Last but not least, baby should know how to print information about itself. Every class should have that. And every class has that actually, but by default it just prints its type. So it should be smarter than that. So let's go back to our baby class. And let's do one interesting thing. Public override to string. String to string. It doesn't have it. Crap. Oh, it does. Okay, good. So, yes, I know. But can you run it yourself? Shit. Okay, I'll do a little demo. I'll just post the screenshot what the console window looks like after the running. Snipping tools is my friend. So when we run the program, we see the following view, which is this. This is the view we see right now when we hit Ctrl F5, which says the information about the baby, and which outputs an error message if baby has faulty data in it. Last but not least, like I said, we should create a few more things about baby. We have a birthday class which is unused, and we should use our birthday class. And we also should print information about baby from the baby itself, and that should be done in the string method of a baby. So we do string interpolation and go back to our main, and this is good enough for starters, the message that we would print. So we copy that here, and we no longer need to reference the baby because it's this baby, this, and just months is the same because it refers to this object. So you have a name, age, and we would like to print when this baby was born. And it would make sense to print it in a separate line for a bit of cleanness. So in a separate line we print birthday is, and now I need to update birthday class. So birthday class should have a month, a month. Let's. Oh, I didn't save our months, sadly. A month should be an enumerator. Can you quickly write enums for me, please? William, I think that's your name. Yeah, capitalist. Month. Thanks for helping. So our month is a casted date time month, and the day is the same. We just did small configuration to take those two from our date time. Thank you. And I didn't write public int day set get, and now we can write our birthday. So birthday is at birthday dot month, and the day is birthday dot day. Let's split it in a separate line. Now it seems quite clean. Our and should remain there, and we don't need a space there. So now we just overridden our toString method with our own implementation. Override means that we write our own implementation. toString is actually a virtual method, so we can override it, but about that in the future. So we have birthday class, which is inside the baby class, and we can use it since baby refers to birthday. Last but not least, let's test it out. Now that we have a way to print information from the baby itself, we can go ahead and do baby toString. Let's run it. Ctrl F5, and I'll copy paste the output. So this is the screen that we have when a baby is made and when the method toString is called. I think someone else managed to run it as well, because I just saw a new screen pop. Anyways, for the sake of cleanness, each class should be in a separate file. So we have our months. Month is considered its own structure, so it should go to a separate file. So I'm moving months to a month file. Oh, we already had. Oh, we already had months apparently. Okay. Now birthday goes to birthday.cs. You should keep one class per file. So that goes there. We also had it here. That's just deja vu. Maybe someone else did it with me. That's why we have it. I don't know. Maybe. Anyways, we just made two classes, baby and birthday, and an enumerator to avoid writing a string for every month. Instead, we write an enum for it. Enumerator is a completely different thing, so disregard that. So we have our main, where we created a bunch of babies, and where we printed their information. So I think it's time to wrap this up. So you just witnessed how an object is made and what a class is. what a scope is. So there are essentially 4 levels of scopes in C#. It is scope of a namespace, scope of a program, scope of a function, and then scope of an if, for, or other language structure. And inside those you can just make your own scopes, such as this one. You can make it. It doesn't matter. It's redundant and it's useless, but you can make those if you want to. So that's about scopes. And classes is like a blueprint for objects, and objects are representations of real life things that we see, that we can touch, that we know about, that are represented by the things they do and the things they are that define them. Our baby was defined by baby class, which had name, months, and birthday. And a baby would be able to tell its information by overriding a method to string. A baby should be able to do more things, such as cry or say something, but we will try to expand this a bit more on the next lesson. For now, it's good enough. Lastly, when you create an object, if it has a chance to have invalid things, you should check for those things. You should fail early if you know that something that is invalid will cause inconsistencies and will simply be wrong. So you should stop and warn a programmer that something is wrong by throwing an exception when you can. So you have count baby months method, which is private for baby. And if in case baby is made in future, it's invalid. Or if baby is older than 36 days, and this should be actually moved to a constant, because we don't plan to change it, or if we do, we don't plan to change it during runtime. So private int baby max months, constant is always in capital. So max baby is 3 months. So to make it more readable, if months difference is more than baby max months, then we throw an exception that baby is too old. Usually you should also make throw your own custom exceptions, but for this lesson, simplicity and scope, it's good enough. And I think that's about it. Okay, do you have any questions? Anyone? Questions? I have hope in you, Storm. Questions? Questions? Good, good. Okay, let's go to baby. Yeah. Yes. This is a shortcut. Set get is a shortcut for this. And under the hood, it looks very similar to this, but except a bit different, but it looks like this under the hood with an arrow, not with that. It's a arrow bodied expression. Yeah. Mm-hmm. Yeah. Yeah. It's Yeah, it's for the sake of writing variables inside a string without, adding two strings together. You still have one string. It's just for the sake of simplicity for writing a string mixed with variables. A string format, yeah, you can. Is it clear why set and get is needed overall? If you go to line 38, set and get, why do you need it? Do you know? Do you understand? Sure, if you yes, but uh, if you know that you need to write and read it, why would you want to? Why wouldn't you want to simply say public int months without the set and get? Why wouldn't you? Okay, it's because go on, explain. Uh, Actually, return, let's say 1. So you can make your own implementations. Oops. And when you set the value, you can say uh, as stupid as it. Well, private. I should probably do it in the one with it, which is custom for the sake of simplicity. Um, so let's say in our name setter, you set the name, and at the same time you can do something like console write line name is whoops name is, and write the name underscore name. So when you set, at the same time you print the name. And if you go back to our program, let's say I created those babies and I for each of them, and I printed the name, I mean information about baby, but at the same time I changed their name random. I called them all random, even misspelled it. So at the same time, when I set the name, I would, if I didn't write the setter getter, and if it was without it, if it was without this thing, then I would need to write this along with this. And then if I changed it here as well, I should write like here. And then if I changed it again in here, let's say I take baby 5 and I change his name here. Again, you see, I write this again. And every single time I'll change baby's name, I'll still have to keep writing it separately, another extra thing that I want to do. So in order to avoid inconsistencies like that and extra code, you can put all the extras when you set it. So an extra goes here. So when you write a set get, one of the other things why you do it is thinking about the future, knowing that you might need to change a lot of code or add something to setting or getting. So you ensure yourself by writing a property instead of public field. That's why set and get. So what's the difference between field and property? Underscore name and name. Yes, but I could just write this, and for the time being it would be exactly the same as this. Uh, the difference actually is that your functions have variables, so do your classes. And if it's just a variable, it's called a field. If it's just a variable. And if it's something that wraps that variable of a class, it's a property. So name wraps underscore name. So name is a property because it wraps underscore name. And underscore name is a field. It's just a simple variable within a class. So that's what. Also, if you don't write public, by default it's private for fields. Uh, so it's private underscore name. For class, if you don't write public, by default it's internal, and it's internal to the project. It cannot be private because you will need it. We will need to use it anyways from outside the scope, so it wouldn't make sense to give private keyword to a class. It's internal. So yeah, that's about it.